Hi everyone. I know what you're probably thinking to yourself. No, 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 not more potpourri. But yes, it is time for some more potpourri. This time, fraction potpourri. So, fractions can be thought of in a couple different ways. A very constructive way to think about fractions, at least in the elementary schools, is in terms of a part-whole relationship. What this means is that you interpret a fraction. So the fraction a over b can be interpreted as a parts, it's going to be a, out of b equal parts of the whole, whatever the whole is. So for example, we talk about a quarter, 1/4 in terms of money, which is 1/4, okay? So 1/4 represents 1 out of 4 equal parts of the whole, and the whole in this case is $1. Note that it's important that we're talking about parts out of whole equal parts. So here's a sort of a common question. Geometrically, each of these regions down below here, the square and the triangle, are divided into 5 parts. In this case, the shaded region for the square does represent 3 out of 5 equal parts. But for the triangle, the parts are not all the same. So the shaded region in this case does not necessarily equal 3/5. Another way to think about fractions is in terms of numbers on a number line. And that's actually something that usually comes a little bit later in maybe upper elementary grades. So a fraction in this case is not a part out of a whole, but some number of the form a over b, where a and b are whole numbers, and it's important that b is not 0. So in the notes that you should have read, all right? So in the notes, it talks about how you can take fraction strips, and through those fraction strips, you can build yourself a number line. Put the fraction strip divided into halves, and you get the fraction 1/2. Then lay on top of that the fraction strip in thirds, and you get the fractions 1/3 and 2/3, and so forth. So you can build yourself a set of number line, if you will, of fractions. Another useful tool for fractions is the fraction wall. And that fraction wall is particularly useful when it comes to equivalent fractions. Okay? So equivalent fractions are fractions that represent essentially the same part. So in this case, we've got 1. This is the wall. And then each of these is 1/2. So equivalent fractions, what other numbers represent 1/2? And what you can do is you can either put a ruler or just draw a straight line and say, okay, are there some other numbers that represent 1/2? Well, in this case, we've got, these are fourths, so 1/4. Each of these is a fourth. So 2/4 is the same as 1/2. They're equivalent. Likewise, down this last row, you've got 1/6, 1/6, and 1/6. Put those together, 1 and 1 and 1, you've got 3/6 also equals 1/2. So you can see lining up the equivalent lines allows you to identify equivalent fractions. Equivalent fractions are probably one of the most important concepts to understand for students when they start to do, for example, addition of fractions. It's very easy. The getting common denominators is essentially equivalent to finding equivalent fractions. So let's think about what we did on the fraction wall. We said that on our fraction wall that 1/2 and 1/4 are equivalent. They line up in the same place. Well, notice that 2/4, 2/4 is the same as 1 times 2 over 2 times 2. We said that 1/2 and 3/6 are equivalent on the fraction wall. Well, note that 3/6 is 1 times 3 and 2 times 3. And I know that you're comfortable with fractions. 1/2 is the same as 11/22, but notice that 11/22 is 1 times 11 and 2 times 11. So in general, to create equivalent fractions, if you take any fraction of the form a over b, you can create an equivalent fraction by multiplying the top and the bottom by the same number. So if you take a over b and you multiply the top by c and the bottom by c, where c is a whole number, c is not equal to 0, then a over b is equivalent to a times c and b times c. All right, another little fraction fact, it's almost a tongue twister. Remember, this is potpourri, so just lots of little facts, is this idea of the density property of fractions. So the density property states that between any two fractions, there is another fraction. Okay, in other words, technically, another word for fractions are rational numbers. Rational numbers means they can be written as ratios, a over b. So the technical term, rational numbers are dense on the number line. That's why they call it the density property. Essentially what it means, between any two fractions, you can find another fraction. So let's see, we've got the fraction here. This is 1/2. We've got the fraction here, which is 2/3. On the number line itself, on the number wall, from the fraction wall, I got it out finally. Can you find a fraction between 1/3 and 1/2 and 2/3? Okay. And go down here and notice, look at that. That number right there. So that is between 1/2 and 2/3. And that number is, these are the fifths, 1/5, and another 1/5, and another 1/5. So the number 3/5 is between 1/2 and 2/3. You can keep going with this. In other words, there's a fraction between 3/5 and 2/3. And then there's a fraction that fits between that number and 2/3. You can keep going. That's one of the reasons that there's going to be an infinite number of fractions. Just a few examples of the density property. How would you find a fraction that falls between 2/5 and 3/5? One tool is to use equivalent fractions. Okay, so what I'm going to do essentially is I'm going to spread out the 2/5 and the 3/5. And the way you spread them out, if you will, on the number line is you use equivalent fractions. So 2/5, if I multiply by 2, is the same as 2 times 2 and 5 times 2. So 2/5 is equivalent to 4/10. 3/5, using the same idea, and notice what I'm really trying to do is keep these denominators the same, is 2 times 3 and 2 times 5, and that equals 6/10. So 2/5 is the same as 4/10. 3/5 is the same as 6/10. Can you find a number that fits in there? You can. It's 5/10. So 5/10 falls between 4/10 and 6/10. But remember, 5/10 is just 1/2. So what that says is that 1/2 fits between 2/5 and 3/5. Okay, those are nice numbers. How about something that's not so nice? Well, notice before what we did is we tried to find a common denominator. And that was a strategy which allowed us to sort of spread out these numbers so I could figure out what goes in between these two. You don't need to use the lowest common multiple, which is actually we'll learn the lowest common denominator, but it makes it a little bit easy to do that. It keeps your numbers sort of small. So this find a fraction, which we know exists by the density property, between 10 over 21 and 5/11. So 10 21sts and 5/11. Okay, so using first of all, find the LCM, least common multiple of 21 and 11, and that is 231. And then we're going to use equivalent fractions. Okay, in other words, we're going to essentially get the denominator of each of these to be 231. So if I multiply 21 by 11, well, again, to create an equivalent fraction, you have to multiply the top and the bottom by the same number. So 10 21sts is the same as 110 231sts. Doing the same thing with 5/11ths, we want the common denominator to be 231. So multiply it by 21. But to create equivalent fractions, you have to multiply the top and the bottom, numerator and denominator, using the correct terminology, by 21. So 5/11ths is the same as 105 231sts. Can you find a number that fits in between 105 231sts and 110 231sts? Well, there's several of them. Actually, there's an infinite number of them. But here's an easy one. 107 231sts fits between 105 231sts and 110 231sts. So that says that 107 231sts does fit between those two fractions, 10 21sts and 5/11ths, by the density property.